Okay, hi everyone. Thank you so much for listening. My name is Amy, and I interned with the National Oceanic and Atmospheric Administration this winter, specifically with the Northwest Fisheries Science Center. So I was working with Dr. Fullerton and Dr. Bond at NOAA, as well as my partner Emily, who is also a Capstone student this quarter. If you guys want to go check out her project. We were working on a project that it was centered around understanding the current state of knowledge around the life cycles of coho salmon in particular, and how life cycle models are intertwined with all of that. So what are life cycle models? Life cycle models are coded statistical models that provide population estimates based on projected changing environmental conditions. These models typically present population estimates using two major metrics, those being survival and capacity of a certain population. And the outputs that these models provide, the population estimates, are then used to inform decisions regarding conservation, restoration, funding, policy, research, and more. While these life cycle models are a really, really valuable tool, they're not without limitations, which is what I was exploring in this project and leads me to my research question, which is what are the barriers and limitations to scientific modeling? So while at NOAA, my partner Emily and I conducted quite a few interviews with scientists and modelers from NOAA, the Department of Fish and Wildlife, the Department of Agriculture, and more in order to get some feedback from them. We also populated a database on GitHub that is intended to house current research and also summarize and synthesize a tremendous amount of literature. In terms of our results, our interviews with the scientists were wonderful and incredibly informative, and we found that the responses that we were receiving really closely were corroborated by literature and critiques of life cycle models that we reviewed. So while these scientists provided us with a really great variety of takes and input, a lot of their thoughts really fell into these two kind of broad umbrella issues, which is what I will be telling you about. So this first issue is lack of data, and this was by far the issue that was brought up the most by scientists. Essentially, these models are built using foundational data so that the model knows the relationship and patterns between the components. And we received a lot of feedback that there is simply not enough data available to make these models as reliable as possible. And you're probably asking yourself, well, why is there not enough data? This could be a variety of things. We've received some opinions that it's because the fact that NOAA is underfunded and doesn't have the resources to do the amount of research that would be necessary to inform these models to the greatest extent. There are also simply some logistical challenges that come with studying live organisms. For example, we have received feedback that there are certain life stages and habitats and things like that where the salmon are way harder to track and understand, which means less data for those portions of the life cycle. And in this white box here is a quote from Dr. Tim Beachy, essentially reflecting what I just told you, and about how difficult it is to get the amount of data necessary. The second category is around this concern that technological models can't really replicate a dynamic living system accurately. So we received feedback that it can be really difficult to construct models that actually match the dynamics of what happens in a real ecosystem. There are, of course, really niche, narrow models that exist. So like, for example, models that will predict the capacity of a stream if the temperature were to increase by like 2 degrees. But some scientists feel that the outputs of those models aren't objectively that useful, as of course these organisms aren't existing in a vacuum, and there are also other components acting upon these fish that aren't being considered. On the other hand, there are also models that are super broad and aim to kind of take into account all the different components acting upon these fish. But knowledge is always evolving, and some scientists feel that there is always inevitably going to be something that is missed, something that is not considered. And how crucial that is something that we're still kind of wrestling with. So to kind of aid you in that, if you look at figure two, I know you can't read the words because it's pretty small, but the words are not like the relevant part. This was a graphic also given to us by Dr. Michi. He created the heart model, which is one of those models that is intended to be super broad and really capture the kind of holistic life cycle. And Dr. Beachy talked to us extensively about how really difficult it is to capture all the relationships. And you can see in this graphic, like the sheer interconnectedness of all these components. The way that he explained it to us was if you picture a big machine with like 40 different dials on it, you have to know where all the dials are starting and then how they're all, informing one another, how everything's connected. And it gets very, very complicated very quickly, especially for life cycles like the salmon, like the coho salmon, which are very complex. Um, which so it is very difficult. And what do we take away from this? Well, as mentioned, it's well known that life cycle models provide us with a tremendous amount of information and are a really, really valuable tool, especially in terms of conservation. That being said, understanding where life cycle models excel and where they pose challenges can help us use this technology more efficiently, and also will lead to more informed, better educated decision making regarding things like conservation for the coho salmon and for the other organisms that life cycle models also help inform decisions about. Moving forward, what do we do with this information? Of course, there are some more broad solutions, things like getting more research done, increasing funding um, to better inform these models, but those are also going to be really long-term, kind of harder to tackle solutions. A lot of the literature that I reviewed came to similar conclusions in terms of like short-term actions. Um, and a lot of those were centered around this notion that no really crucial decisions should be being made based off of one output or one piece of information. Instead, we should reframe the way that we use life cycle models and have them be part of a larger system of tools that can collectively provide a more diverse and varied look at these issues. Furthermore, of course, advocate and support for organizations like NOAA to receive the funding they need in order to continue to further the knowledge and research in this area. Um, and make sure that organisms and populations like the coho salmon continue to stick around and thrive. Um, yeah, thank you for listening. Um, yes, thank you.